Good evening, everyone. Here are your notes for lesson 4.3. Hopefully you can get these done Friday night so you can have the rest of the weekend to enjoy. Today we are going to be working with properties of exponents, and there are 3 different properties we are going to be working on this evening. I feel they're pretty easy. You're going to have to make sure you pay attention because I don't want you to confuse the 3 properties together. Within themselves, they are very easy. Let's go ahead and look at, excuse me, our first problem. The factors of a power, such as 7 to the 4th, look at how they can be grouped. I have them grouped here in 3 different ways. In the first way, it looks just like we've been working on in class. 7 times 7 times 7 times 7 is 7 to the 4th power. But in my next 2 examples, I've now inserted parentheses. In example number 2, you'll notice that we have 3 7s grouped together inside of a parenthesis, and that is being expressed as 7 to the 3rd power. And then there's this one lonely 7, which is 7 to the 1st power. Altogether, there are still 4 7s in that group. So that is why the answer is still 7 to the 4th power. And in my third example, you'll notice that I have 2 7s grouped together, so that's 7 squared, and then another set of 7s, which is 7 squared, and again, our answer is still 7 to the 4th power. There are still 4 7s, we just have some grouping symbols. So let's talk about multiplying powers that have the same exact base. Anytime we multiply powers with the same base, we keep the base and we add the exponents. It's as simple as that. The base stays the same, add the exponents together. So the example here given to us, 3 to the 5th power times 3 to the 8th power. Notice the base stays the same, we add the exponents together, and the answer is 3 to the 13th power. We're going to go ahead and try a few here together. Problem number 1, 6 to the 6th power times 6 to the 3rd power. The bases are the same. Our exponents, we need to add them together. And yes, ladies and gentlemen, I want to see you write this down when you're working these out so you don't make any silly calculation errors. And that becomes 6 to the 9th power for our final answer. Now let's try one where we have a variable as our base. The base is the same, so n. We have 5, and to 5 we are going to add 7, and the answer comes out to n to the 12th power. Pause the video, try the next 2 questions, restart, and see if your answers match mine. 24. And we have the exponent of 4 and the exponent of 4. So 24 to the 8th power. Now I'm hoping on this next one, before you started, the 2 that does not have an exponent, I hope you gave it an exponent, and the exponent you should have given it is a 1. So the base is 2, and let's add our exponents. 5 plus 1 gives us 2 to the 6th power. That's multiplying powers with the same base. Let's take a look at when we divide powers by the same base. So notice we have this problem, 5 to the 5th power divided by 5 to the 3rd power. In the numerator, all I've done is I've broken down that 5 to the 5th power into 5 times 5 times 5 times 5 times 5. And I did the same in the denominator, 5 to the 3rd power, so I put 3 5s. Remember, anytime you have a number in the numerator that is the same as the number in the denominator, you can cancel them out. Remember my fun little song, "Do you see what I see?" So we cancel those out. We're left with only 2 5s in the numerator, and we're going to write that using an exponent. So the answer is 5 squared. Now, rather than writing all of these numbers out, the simple way of doing that is to divide powers with the same base, keep the base, and subtract your exponents. Again, give an example. 6 to the 9th power divided by 6 to the 4th power. The base stays the same. It's 6. Subtract those two exponents, 9 minus 4, and the final answer is 6 to the 5th power. We're going to go ahead. I'll do 2 problems with you, and then again we'll pause the video, you try 2, and then start it back up again. Let's start with the first question. The common denominator is E. Common denominator, Mrs. J. The base is E. The exponents are 10 and 5. 10 minus 5 is 5. Our problem should be E to the 5th power. Final answer. Now let's move down. We're going to use or solve the problem that has 7 as our base. 7 is our base. Exponent, 5 minus 3. Final answer is 7 squared. Now please note, I'm not solving this. I am not writing 49 as my answer. I am writing my quotient as 1 power, so I'm simplifying. Pause the video, try the next 2, and come back and check. The base we have in common is x. 10 minus 9. Yes, that's 1. You can write this answer as either x to the 1st power or just plain old x. And now let's go ahead and do another. 9. And our exponents we are subtracting. 9 minus 2. And the answer is 9 to the 7th power. Okay, quick recap. We have multiplied powers by the same base, and when we multiplied, we added our exponents. Now we've just worked on dividing powers with the same base, and so we subtracted our exponents. And now we're going to move on to raising a power to the power. So anytime we raise a power to a power, notice the problem. Let's take a look. We have the base of 9, and it's raised to 2 separate powers. To raise a power to a power, you're going to keep the base and multiply your exponents. So again, to raise a power to a power, you are going to keep the base and multiply your exponents. So how do we read these problems? Well, whenever we see a question like this, we are going to read it as 9 to the 4th to the 5th. That's an example that I have for you here. Let's go ahead. We're going to try. We'll do the first one. 5 to the 4th to the 2nd. The base is 5. We need to multiply our exponents. So 4 times 2. And our answer is 5 to the 8th power. All right. Base is 17. multiply your exponents. 2 times negative 20. 2 times negative 20. Yes, we can have negative answers. 17 to the negative 40th power. Try the next two. Turn the video back on. Let's see how you did. The base is 6. We have an exponent of 7 and 9. So let's multiply those together. 7 times 9 is 63. 6 to the 63rd power. And our final question. Yes, ladies and gentlemen, you can have a fraction as a base. So the 2/3 is going to stay. The exponent is 12 times negative 3. And when we multiply 12 and negative 3, our answer is negative 36. So 2/3 to the negative 36 power. You don't want to try to solve that. That is going to be crazy if you try to solve that one. We're going to leave them in using powers. Okay? So, I hope that you found this lesson to be pretty easy. I would like for you to try all the questions, numbers 1 through 12 on page 172. And again, I hope you all have a great weekend. Get outside and enjoy the beautiful weather on Saturday. And I will see everybody in class on Monday. And guess what, Madeline? I'll have a foldable for you when we come back. Good night, everyone.